At the Saskatchewan Agronomy Research Update in 2021, I discussed whether variety selection has an impact on nitrogen management for malt barley and milling oats. The first question to answer is, do new malt barley varieties require more nitrogen than the old ones? It makes sense to me that they would, because typically a higher yielding variety has less protein. You certainly can see that with differences between wheat varieties. Now, this isn't good when you're dealing with a hard red spring for human consumption, but it's great for ethanol wheat varieties or malt barley. Less protein means more starch to turn into alcohol. So do newer, higher-yielding malt varieties have less protein compared to the old, lower-yielding AC Metcalf, for example? Well, if they do, maybe we should be fertilizing these varieties differently with nitrogen. So a trial was developed by Mitch Japp, who's now with Sask Barley, and Shannon Chant with the ministry. The project was supported by the Strategic Field Plan. The trial was conducted in 2020 and during the drought of 2021. Locations included Melfort, Prince Albert, Swift Current, and Yorkton. Let's first look at the crappy drought year. You can see yields are quite low, and yields were quite unresponsive to added nitrogen, which includes the soil background nitrogen plus added fertilizer. The blue line is Metcalf, and Metcalf is usually the lowest yielding variety, and the orange line is Synergy, which is usually the highest yielding variety. All the varieties tended to be low and unresponsive to nitrogen. If we look at their proteins, we can see they're through the roof. Normally, maltsters are looking for protein levels between 10 and 13%, and some of the Asian markets will go as high as the 13%. But you can see here that our proteins are through the roof. Even when we have applied no nitrogen at all, the background level of soil nitrogen of 70 pounds was enough to throw proteins into the 13 to 15% range depending upon the variety. The variety AC Metcalf tended to have higher proteins than the higher yielding AAC Synergy, even though in this drought year we didn't see any yield differences between the varieties. So in the drought year of 2021, yields were unresponsive to nitrogen, and high proteins provided us with no information really to suggest varieties should be fertilized any different from each other. But in 2020, things were different. Here you can see we've got some beautiful response curves to added nitrogen. The blue is Metcalf, and it's lower yielding and less responsive than the orange line above, which is Synergy. Bow is in the middle. Protein levels were better too. They're down more into the 10 to 13% range. You can see that the blue Metcalf protein response is higher and more responsive than, say, AAC Synergy, the orange line. And this is great, because this is exactly what I was hoping to see. For a given rate of nitrogen, AC Metcalf is going to have more protein than Synergy, which means it can't be fertilized with as much nitrogen. So let's just take Bow out of the picture so we can focus on the two extremes. But if we consider 12.5% protein the maximum amount of protein we want to aim for, then this is reached when we get to 115 pounds of soil plus fertilizer applied nitrogen for Metcalf. For the Synergy, it doesn't reach 12.5% protein until we've applied 150 pounds of soil plus fertilizer nitrogen. The background nitrogen in the soil in this slide is 40 pounds per acre. So in reality, for the two varieties, we're applying 75 and 110 pounds of nitrogen as fertilizer. If we fertilize both varieties at Metcalf's safe rate of 115 pounds of nitrogen, this will result in a 7 bushel per acre yield advantage for Synergy. All things being equal, Synergy is clearly going to generate more revenue. But wait, we can push the nitrogen rate more for Synergy before it gets to that 12.5% protein. we can go all the way up to 150 pounds of nitrogen per acre. When we increase synergy to 150 pounds of nitrogen, we're now generating an additional 6 bushels per acre. But this came at a cost of added nitrogen. So how does this work out economically? So I'm going to use some older figures for prices. I'm going to use just 50 cents a pound for nitrogen and $5.20 per bushel for malt barley. When we look at the rate of nitrogen of 115 pounds of nitrogen per acre, which is the safe rate for Metcalf for both varieties, Synergy has generated $39 per acre more income. But after increasing the nitrogen rate to 150 pounds per acre, AAC Synergy is now generating $52 per acre more income than the AC Metcalf at its 115 pounds of nitrogen rate. So the conclusion of this study is that we should be applying more nitrogen to Synergy relative to Metcalf. The study would suggest we should be applying 35 pounds of nitrogen per acre more. Am I comfortable with this as a recommendation? Not really. This is just one study and it does seem like a lot. However, the study does support that if growers are switching from Metcalf to Synergy, they probably should experiment with applying a little more nitrogen. So moving on, how should malt versus feed barley be fertilized? Well, here's a study that examined that question. Conventional wisdom has been to apply more nitrogen to feed barley than malt. Historically, feed has been higher yielding than malt, and we don't need to worry about excessive protein with feed. The Saskatchewan Crop Planning Guide assumes that we are putting 102 pounds of nitrogen per acre down for feed and only 83 pounds of nitrogen per acre down for malt in the black soil zone. Now, I've cherry-picked these examples from our study, but there was only one case to support applying more nitrogen for feed compared to malt, and this was due to excessive protein occurring for the malt. Here we're looking at the yield responses for AC Metcalf and the feed variety Ossison. AC Metcalf is in blue, and the feed variety is in orange. The gray line shows you where the protein level is for AC Metcalf, because there's no point in saying the most economic rate of nitrogen is beyond the rate of nitrogen that will exceed 12.5% grain protein. In this particular year and location, we can see that AC Metcalf and the feed variety have very similar optimum rates of nitrogen for the best economic return. The higher price for the malt results in a higher economic N rate, even though the feed was more responsive. Let's switch to another site that compared Synergy against Ostenson. Those two varieties have very similar yield responses. And protein was still pretty low for the malt variety. So in this particular instance, the most economic rate of nitrogen for the malt is actually much higher than it was for the feed. This intuitively makes sense because the malt is worth $4.68 a bushel and the feed was worth $3.70 a bushel in this example. At another site, our nitrogen rates didn't go high enough to perfectly predict the most optimum rate of nitrogen for feed and malt. But in this case, we're comparing Synergy and Ossison again, which have very similar yield responses. The proteins are very low, and by all accounts, if we had gone a little higher with the nitrogen rates, I wouldn't expect the most economic rate of nitrogen to be higher for the feed, simply because of the price differential between malt and feed. Conclusions. The most economic rate of nitrogen wasn't usually higher for feed compared to malt. This makes intuitive sense to me, particularly if the malt and the feed varieties have the same yield potential. With similar yield potentials, malt's most economic rate of nitrogen is going to be higher simply because the grain has greater value. Of course, this is only true as long as the maximum allowable protein of 12.5% is not exceeded. But it usually wasn't exceeded because there isn't typically much more yield potential to be had once grain protein reaches 12.5%. However, nitrogen rate has to be based on your risk tolerance, because too high a protein means rejection for malt. So as a result, I'm not going to suggest that you should fertilize your malt with more nitrogen. I'll turn it around. I will suggest it might be worth fertilizing your feed barley with rates similar to your malt, but not more, if your high-yielding malt varieties are typically over 12% protein. Okay, I'd like to switch to some oat test weight studies that we've been doing over the years at Yorkton. I like to call this oat test weights in the good times and the bad, meaning good growing conditions and drought. In Yorkton, we've been involved in oat test weight studies for a number of years, and grain millers, which is based out of Yorkton, will discount oats if they're below 245 grams per half a liter, and will outright reject them if they're below 230 grams per half a liter. In a year like we've had this past year, I think they've loosened those restraints a little bit just because there's been so much low test weights in the area. But things that I know for sure is that test weight is reduced by increasing nitrogen, and test weights for Summit are always higher than those for Camden. As far as environmental effects, I don't really get it. More on that later. So let's start with our good year first. The blue lines represent the yield response. The orange line represents the test weight response. You can see for Camden and Summit, we've got some pretty good yield responses to added nitrogen. The background level of soil nitrogen in this study was 35 pounds of nitrogen per acre. You can see that the test weight is declining for both varieties. The green arrow shows you the test weight below which you will be discounted. The purple arrow shows you the test weight below which you will be outright rejected. Now you can see that Summit falls within the discount range, but never falls below the rejection line. In contrast, Camden is dancing along the bottom of the rejection line for many of the higher rates of nitrogen. So let's now compare this against the drought year we had in 2020. Yes, Yorkton had a drought year in 2020 and 21. Lucky us. So you can see here that our background soil nitrogen in the drought year is 60 pounds of nitrogen per acre. And our yield response, the blue lines, for both varieties is very flat. Hardly a response at all. But look at our test weight lines. Summit is just flying high. It's way above the discount range. Even Camden is above the discount range for all of the nitrogen rates, although it is lower than Summit. So it looks like a drought is good for test weights. But wait, let's bring in another drought year and see what happens. So now we've brought in the drought year of 2021. And you can see that we have a pretty flat yield response for both Summit and Camden. And this is not surprising, particularly now that we're sitting on 92 pounds of background soil nitrogen. The joys of back-to-back droughts means your soil nitrogen just keeps climbing. But look at Summit. The orange test weight line falls into the discount range, but never falls into the rejection range. Now you may think that I've forgotten to put in the test weight line for Camden oats, but it's actually so low it's fallen below the range of these charts. It is majorly getting rejected at every nitrogen rate applied in this study. So there you have it, high test weights in the drought of 2020 and low test weights in the drought of 21. I really don't understand how environment affects test weights. We also looked at the effect of seeding rate on yield and test weight. Our seeding rates went from 100 seeds per meter squared up to 500. Not surprisingly, there isn't much effect on yield, and there wasn't much effect on test weight either for Summit. Summit just sits in that discount range for the entire range tested. Here are the results for Camden oats. Oops, that test weight line has fallen below the scale of my graph once again. Here, I'll change the scale so you can see it. You can see now for Camden that test weights are just getting crushed by higher seeding rates. They've gone all the way down to 205 grams per half a liter. Nobody's going to accept that. So, it's interesting. Increasing seeding rate didn't affect test weight in Summit, but it's crushing it for Camden. Conclusions. Summit maintains better test weights in the good times and the bad, better than Camden. This was true for any precipitation level, any level of nitrogen, and any seeding rate. So with these study results, I have showed you that the optimal rate of nitrogen can vary between varieties. A high-yielding malt variety may need more nitrogen compared to an old low-yielding malt variety like AC Metcalf. Feed varieties of barley probably don't need as much nitrogen compared to a modern high-yielding malt variety with a grain protein over 12%. N rates can be pushed more with the oat variety Summit than Camden, with less fear of reducing test weights too low. That's it. Questions? That's all she wrote.